Hi, welcome to this tutorial. In this video, I'm going to show you how to set up multi-cloud Kubernetes cluster. Here, my master will be in AWS, one worker will be in GCP, the other will be in my local machine. I'm going to use a client VPN endpoint to set up the network, so all my machines will be connected on the same network. They are not really connected on the same network physically, but virtually they are connected on the same network. And for that reason, I need to generate a certificate for the server and for the client. So I'm going to use what is available in the documentation of AWS, which is EasyRSA, to generate all the certificates and keys. So let's get started. You are going to find this repository in the description. So for the requirements, you need an account at AWS as well as GCP. You need an EC2 instance, which will be your master. You need also instance in GCP, which will be your worker, and your credential of AWS access key and secret access key. The OS used here is Ubuntu 22. So inside each script you will find the links to the documentation. We are going to start by script 1 here. So in script 1 I'm going to use mutual authentication, which is available in this link. First we are going to clone git repository and then get inside the directory and then initialize the PKI environment. Then we are going to build the certificate authority and then generate the certificates and the keys and sign them by this certificate authority. After that, you are going to create a folder and copy all the certificates and keys to that folder. Notice here that I have changed something. The script is different than the documentation. So these comments, multiple line comments, are replaced here in the script by a single line. This line will find all the certificates and the keys and then copy them to that folder, custom folder. Then after that, you are going to install AWS CLI and use AWS configure to log into our account. Then we are going to import the certificates to the certificate manager at AWS. At the end, we will check if our certificates are really imported or no. So let's get started. The first step is to clone the repository. After that, you are going to make script 1 executable and then run it. At the end, our certificates and keys will be uploaded to certificate manager. Here, give a name to your certificate authority. I'm gonna name it VPN endpoint. Yes, for certificates of the server. And then for the client, AWS CLI is already installed in my local machine. That's why I get this output. Then you need to enter your credentials. I have already did that. Notice here the region that I use is the same region where my master. Hit enter. As you see here, my certificates are already imported. The last comment will list all the certificates imported in the certificate manager at AWS. We can check that also manually. Head over to certificate manager in AWS. And then list certificates. And here is my certificates for the client, and this is for the server. Let's move to the next step. So step 2 is to create the VPN endpoint. And of course here we need to associate the target network, which will be the subnet of our master. For the authorization rule, we are going to authorize the access to this subnet. So all of my machines which are connected to the client VPN endpoint will get access to that subnet. I can give them access to the entire VPC, but I'm going to restrict the access to this subnet only. And then we need to enable also the split tunnel. This is because in my local machine, if I don't enable the split tunnel, when I connect to the client VPN endpoint, I will lose access to the internet, and therefore I have no longer access to my GCP worker and my master. And the most important part, I will have no longer access to the AWS console. Therefore, I need to enable the split tunnel. So let's get to the VPC dashboard to create that client VPN. Scroll down to client VPN endpoints. So here, click create client VPN endpoint. Name it VPN endpoint, for example. Now the side range, I'm going to choose 10.2/16. Therefore, my clients will get an IP address in this range. For the authentication part, select the server here, certificates, use mutual authentication, then select the client certificate. And as I said, I must enable split tunnel. Then the VPC, I'm going to choose, of course, the VPC of my master. Security group the default one. Then create client VPN endpoint. It is successfully created. Now we need to associate target network, which will be the subnet of my master, the VPC here. So as you can see, I have multiple subnets. I must choose the one of my master. So this is my master. Going to check the information about my master. This is the VPC of my master, and this is the subnet, which ends with ED4. Let's choose that. ED4 here. Associate target network. So that's done. Now we need to add an authorization rule, which will be restricted only to the subnet of my master. But for that, I need to get the side range of the subnet of my master. Let's open that. So this is the subnet of my master. This is side range. Copy that. Head back to authorization rule. Yes. I'm going to allow all access to all users. So the VPN endpoint will be ready in 10 minutes. Let's get back to the repository. So after creation of the VPN endpoint, we need to download the VPN configuration file, then rename it and move it to this directory. Notice here this directory is already created by the script in step 1 here. Inside the script, you will find a command to create that folder. Now, going to download the client configuration file. Download. This is client configuration file. I need to move it and then rename it. Let's create the terminal. Now, copy home, download. There is a parenthesis in the name of the file. For that reason, I need to add this dot ovpn. Going to move it to the DevOps, to the home, DevOps, and then custom folder, the name client dot ovpn. That's done. Let's check that. So this directory contains all the certificates for the client and for the server, and here is the client configuration file. After that, we need to add the path to the certificates of the client and the key. So let's edit that file. VI client. No, of course, I'm not in the right directory. Let's get to that directory. Now VI client VPN, and you need to add those two lines here, and of course you need to add your path. Then save it. After that, I need to copy that directory to all my clients. So here I have two clients, my machine and the GCP worker. So let's copy that directory to the GCP worker. First, I need public IP of my GCP worker. This is my GCP worker, and this is my master. So let's copy public IP. I have already established an SSH connection to both machines, my master and GCP worker. So that should do it. We have an error here. So I'm going to remove that folder because it contains SSH session, previous SSH sessions, .ssh, known hosts. Wow, let's try again. Yes, that's done. Let's check that SSH2. I'm inside the GCP worker, and here is my folder, and here is files. So that's done. The next step is to install the client OpenVPN and then connect the clients to the client VPN endpoint. So let's do that. Worker GCP. In my machine, I have already did that. So that's done. Now we need to wait until the client VPN endpoint to be ready. Let's check client VPN endpoint. So it's available. I can connect to it. Hit that command. Going to start by GCP worker here. Dash dash daemon is to for running this command in the background. Hit enter. That's done. My local machine. That's done. Let's check that. I type in IP IDDR IP address. As I mentioned before, my clients will get an IP address in this side range. So here I have a tunnel interface with this IP address 130, and for the worker in GCP IP DDR, this is the IP address. We can check that also here from the console connection here. Here I have two connections, one at 162 and the other at 130. Now let's move to the next step, which is running script 2. Script 2 is used to prepare all the nodes for bootstrapping the cluster. Let's get inside script 2. So first we are going to install Docker using the script downloaded from Docker page. Then there are some configuration about containerd because we are going to use containerd. There are two ways to enable the CRI on the containerd configuration file. One way is by editing this file and commenting the line that contains disabled plugins. Then restart the containerd using systemctl. And of course here you need to be root or at least sudo. Another automatic way is to use those commands. First command is used to generate the default configuration for containerd and then upload them to the file and then modify the C group. After that, restart containerd. After that, we have here to enable IPv4 forwarding and IP tables, and then at the end installing kubeadm and kubelet and kube control. So let's do that. And of course we need to do that on all the nodes. So first I need to copy script 2 to all the nodes. So for that I'm going to use from my machine here as I did before for this cp, going to script 2, and of course script 2 is not in this current directory, then home, multi-cloud, yes, then script 2, I need GCP public IP, so that should do it. That's done. Now for my master, I need to grab first either the private IP or the public IP, because I have here VPN connection here, so I can use the private IP. Here first I need to specify the user because it's not the same as my local machine. Then the private IP, and of course here for AWS I need to specify the private key, which is in home, DevOps, downloads, keeper. That should do it. Yes. So that's done. Let's check that in the GCP. So script 2 is here. For my master, I need to establish an SSH session to my master event to the user, then private IP, then of course the key. So on the side, so script 2 is here. After that, we need to turn it executable by adding X here and then run it. Let's start by the master. That's done. And for GCP, that's done. And for my local machine, I have already did that, but doesn't hurt. I did it again. Of course, it's not here. So I'm going to its directory, home. Now we wait till it ends. So that's done for my machine and for the GCP and for the AWS machine also. After that, we are going to initialize the cluster on the master using kubernetes. So go to your master, copy the command. Here we need to run it sudo, and of course we need the private IP here. So the private IP is already here. I just need to replace dashes by dots. And here also. Here I have an error because I have used T2 micro, which has only one CPU, and here the minimum required number of CPUs is 2, and for the memory is 1700, but we can override that behavior as it said here using this flag. So copy it and paste it. We need two flags because we need one for the number CPU and the other for the memory. This is for the CPU and this is for the memory. Now we wait. So that's done. At the end, we need to run those commands. Otherwise, kube control will not work. So kube control, get nodes. Now we will join the workers using this command. Start by the GCP worker and we need to run it as sudo. So that's done for the worker GCP. Now for my machine, sudo also. I have an error here because this machine was a node of other clusters. For that, I need to use kubadm reset, of course sudo. Yes. At the end, I need to remove directory. Now our command should work. So that's done. If you do here, now keep control, get nodes, and get all the nodes. So as you see here, my nodes are in not ready state, except my local machine is in ready state because it was a member of in another cluster. That should be the reason. After that, we need to run or to install Weave CNI plugin. That's why our nodes are not ready. Oops, I need to copy the comment. Yes. So that's done. Now let's check the nodes here. Get node dash watch. Worker at GCP is ready. Suite for our master. Yes. So our master is ready. Let's check again. All the nodes are ready, including the master. So that's it. At the end, if you need to test your cluster, of course, we're going here to run a pod and expose it with a cluster IP service. After that, you are going to navigate to the IP of the cluster IP in our browser here and see if it works. Let's do that. I am in the master, that's good, yeah. Hit enter. Already created. Cube control. Get pod. Running state. You need to see all the pods. Dash A. They are all in a running state. Everything is good. Now we need to grab the IP of the cluster IP service. Cube control. Get service. This is IP. Now let's see if our nginx is functional. So as you can see, it works just fine. At the end, you need to clean your infrastructure, especially the client VPN endpoint, because it is not free tier. And of course, you will be charged less than $1. So let's do that. First, you need to delete the associated target. Then you can delete client VPN, otherwise you cannot. Delete. Now AWS master, I don't need it anymore. Terminate my GCP worker. Supprimer. So that's it. Thanks for watching. See you next time.